Alright, so to review, we looked at the three zones of the Earth. So we have the atmosphere, which contains all of our gases. We have the hydrosphere, which contains all of our water. And then we have the lithosphere, which is all of our minerals on the Earth's surface. Inside the Earth, we know that in the center of the Earth, it's the hottest with the highest amount of pressure, the highest amount of density. And then as we go out, once we reach the surface, it's the coldest, it's got the least amount of pressure, and it's the least dense out of all of the layers. We know that there's layers there because of measuring the waves caused by earthquakes. And there's two different types of waves, and we're going to talk about these a little bit later on, but it's good to kind of have heard about them, called S waves and P waves. S waves have a large shadow zone because they don't go through liquid. So we know that there's a liquid outer core. And we know based on the two shadow zones that are for P waves that there are different layers inside the Earth, and we know some characteristics about them because of this. So we talked about first about the mechanical layers of the Earth. So we have the inner core, then we have the outer core, then the mesosphere, the asthenosphere, and the lithosphere. And we said that the way to remember this is outside of the inner core and outer core, the other three layers go in the order that they would in order to spell mantle. So M, A, and then L. Okay? So we know our compositional layers. So this is the crust, whether it be continental crust or oceanic, then the mantle, okay, that consists of the asthenosphere and the mesosphere, and then finally the core that consists of the inner and the outer core. We know plate motion happens because of convection currents. So we have this like heating up of the magma. It reaches the top, it kind of runs along the plates and then comes back down because it gets more dense, and then it kind of runs along the outer core, heating up, gets less dense, rises up again. And these convection currents kind of push the plates apart. But once the plate starts kind of coming down, we get what's called slab pull, which causes the plate to subduct even faster. Yeah, with that, that's it. That's a great review. Make sure, though, that you do know kind of what the main materials are in each one, which we just haven't covered in this review.